Good morning to you all. So we're going to complete previous lecture. I did explain some of these materials using Zoom, but I'm gonna recap them very quickly. Uh, so you will have it on record as well. Okay, so I'm gonna put it on the slide. So it's a general overview of forensic science. That, like I said, we explained it before, some of it. So we asked these questions, and you should be able to understand what is forensic science in general. Is it a science of police investigation, or is it a proper science like physics and chemistry and biology? And you've probably seen some of these CSI movies as well. So we're going to cover these intended learning outcomes. We're planning to define forensic science and its major disciplines. What are they? We're going to describe the steps in a crime scene investigation, how the investigation kickstarts, and we're going to identify physical and biological evidence. In terms of biological evidence, in previous lectures, we covered those um, comprehensively. So uh, we will recap them, but we focus on physical evidence rather than biological evidence. And then we're going to explain how we're going to collect them. Obviously, we're going to recognize the role of forensic police and lab scientists, you as a lab scientist. So is it is a police work, or is it a proper scientific work? Okay, so let me get my pointer. So we said forensic science involves the application of all the sciences, right? Biology, chemistry, physics, medicine, criminology, everything. Law sometimes involves philosophy, sometimes involves history and geography. So everything we know in science, okay, it will be applied in forensic science and forensic investigation. Because the thing is, we have a problem, a crime been committed, whatever it is, it's still a crime. So we need to use every available tools to solve that crime. So we have a crime scene, a stealing, a rape, a murder, killing, whatever, homicide, whatever happens, you will have a crime scene. So what do we do in a crime scene and to take it to court for the evidence to be admissible by judge and the jury as well? So those kind of things. We talked about these things in detail, the juries is and what is the admissible and inadmissible evidence and why do we need to be careful with evidence. But today we're going to see a general overview of all of this. So, crime scene. So, forensic science generally have four pillars. Let's call it pillars, right? Four columns. They're all important, but in no particular order. I just start with criminology or criminalistics. Criminalistics involved everything to do with crimes, physical evidence. We're going to talk about them: fingerprint, footprint, blood spatters, things, tools, things left in the crime scene by the victim or by the perpetrator. Anything, personal things, mobile phones, keys. So they're all evidence. Okay. Trace analysis, things that we can't see straight away, but nevertheless, they are still in the scene. So things like powder, things like latent fingerprint and fingerprint that we can't see, quite a lot of things really. And the second thing is toxicology. So that was criminalistic. Criminalistics, okay, it's no easy terminology. So I suggest, as you watch the video, take notes, and like we've been doing in classes, take notes and try to understand these words straight away. Toxicology, poisons and drugs, you know much about it, so I'm not going to focus on it. Forensic biology, again, is your area of expertise, and I think you've done lots of biology, DNAs, blood fluids, and everything. And we covered in the previous lectures, we covered quite a lot about body fluids, salivas, semens, and blood, and things like that. So things in biology will be related to forensic. And another new topic that we're going to focus on is ballistics. Ballistics is anything to do with firearms and striations. Striations means كردي تخطيط يعني خط هيلكاري. Okay, so you understand what we mean by this. Uh, firearms, any weapons that fires bullets. Okay, so start a little pistol and goes into a really big missile or whatever. So this is called ballistics. Okay, we're going to focus on that. So how is the CSI protocol happens? We talked about it. You know, we secure the premises and we survey, we document everything, and we start searching and collect the evidence and we package them. Obviously, we will have chain of custody. We cover chain of custody before. We know how we do chain of custody, so be careful. You know, you don't. You need to relate all this knowledge that you acquired in the course back to each other. So when we say chain of custody, it's still the same chain of custody that we've learned. Okay, we talked about scene securities is very important, contaminates, creates doubts, and previously we talked about it that any little doubts in court will render the evidence inadmissible. Inadmissible in court, that means not acceptable. Okay. What is the investigator's roadmap? So we as a forensic scientist, applied forensic scientist in clinical labs, we're not going to a crime scene. The crime scene is all police work. So, but what we do, merging forensic science with clinical discipline, secure the scenes in laboratory analysis. We send in the evidence to laboratory analysis, and the tests we do, presumptive and confirmatory. We already learned these two things. Integrity, again, we learned it. Chain of custody and evidence collection, so important. And the analysis, this is our job, right? Not just clinical analysis, every other analysis, calculated angles and interpreting trace data and those kind of things is our job. So the first thing is after you secure the premises, the crime scene, you look into everything, you document everything. We have this, we have that, we have a body, we have a knife, we have a gun, it's in a garden, whatever you do, you document everything. Then the search starts. Okay, so how do we search? Very quickly, we've already done it. We have two perpendicular search, we have inward and outward circle, we have a parallel path, and we have divided sections. And each of these sections best for, be careful that this is an important exam question. What are they best for? As I take an example, a divided section, the search is for indoors or rooms. In apartments, it's easy. You know, you don't have one big field or one big area. You have divided areas. You have different rooms, kitchens, and living rooms and everything. So you need to use divided sections. This is what it's good for. Like I said, we covered all this before. You just need to recap them. Integrities and preservation on this side chain of custody. I'm not going to talk about it again. You know how to do date, time, collector, description. We've already done it. We've done a quiz in it. But the packaging is important. Again, we explained it. Wet blood goes in a air dry paper, never goes in plastics, mold and degradation. Firearms needs to be in a rigid box because of accidental triggers. Traces like hairs and fibers, they go in a special druggy foil bundle. Gunshot residue, GSR, needs to be picked up by adhesive stubs, special adhesive materials that you pick up these gunpowders and you send it to microscopic analysis. Microscopic analysis could be optical or scanning electron microscopes. We already talked about this before as well. So you know how you have to sort of fold the fiber and the hair and the powder as well, the gunpowder. Fingerprints, again, we explained it really well. Mainly, everybody's has different fingerprints. We have loop, we have hole, whatever you want to call it. Some people don't pronounce the H. It says, some people says hole. Is, you know, it depends on if you are British or American. They have different pronunciation as they have for everything else. Arc is easy. So we have different three different things, and then three different fingerprint patterns. We have three types as well. We have invisible and visible and 3D impression. These two easy, and again we talked about them. I want to focus on this one here. 3D impression. 3D impression. These are plastic. These are plastic fingerprints. You get it on fruit, on wax, on soaps, on body as well. Things are soft. Things are soft that you can actually imprint your fingerprint on it, and that will be picked up in a special 3D impression. The important thing in fingerprint analysis is minutiae points, little points like where the ridge starts and where the ridge ends. As you can see, where are the deltas? This is a deltas. So, you know, fingerprint analysis is a huge area of forensic analysis. We're not going to spend our time on this. We just have an idea. I have explained it in the Zoom session before, and this recording will be able to help you as well. Again, we don't have just fingerprints. We have footprints. Footprints is one of the important as well. Tire marks, tool marks. So it takes us back to the source. The source, I mean, you know what sort of tire marks it is, and you can relate it back to the vehicle being used in the crime scene. And again, shoe prints of footprints, you know, the size, the brand, the design, they all go back to one thing. Who was it? Okay, who's wearing this type of shoes? So if you have a suspect which wears 43 and you picked up a footprint which is 43 Nike with these special characteristics, and the suspect have the same shoes on, it narrows it down. It's not 100%. Okay, like we said, it's not 100%. It narrows the suspect pool. Look at this, narrows the suspect pool. So you might have 20 people suspect, but then it narrows it down. Only 2 of them have that shoe, so you release 8 of them because they're not been in that crime scene. Well, theoretically, biological evidence, we covered it 2-3 times because we've done lots of lectures on blood, salivas, and semens. We're going to focus on semens and sexual assault a little bit more, but in the Zoom session, I've talked about it as well. I think I was up to here in the Zoom session, so I'm going to slow down now to so you can catch up. Blood stains is an important physical and biological evidence. You see, it could be physical evidence by looking at it, what it is, what sort of blood is this, why is it there, what we call a blood stain patterns analysis, BPA. And it could be biological evidence. You take it into to the clinical lab and you analyze the blood for everything, the simplest thing, blood type. So the passive ones, obviously, you know, just dropped under gravity. Somebody's hurt, somebody's wounded, and the blood drops under gravity as it does. Okay, like every other liquid. And transfer, somebody's put their hand in the blood, hair in the blood, food in the blood, anything, okay, in the blood, and they smudge and leave handprints on the walls, on the surfaces, and everywhere. That's another type. Other type of blood stains is projected. Projected, that is been forced. Okay, so blood spatters can be forced through weapons, whether it's a knife stab or a bullet that can, or a push or a hammer hit. Something will break something in the body, and blood will be spattered on surfaces, usually on floorboards, on walls, and kitchen and surfaces, maybe even not necessarily hard surface. It could be soft surface like a bed, sofa, carpet, anything. Okay, so we're looking for types of spatters, where the spines and tails. So spines and tails are indications of the force. So these are spines. It will tell us, what force has been used. You see, according to this long spine, it shows that a great amount of force was used to spatter this blood stain. And what was it called? And the tails, these are the tails. The tails are telling us which direction the blood spatter is going. It looks like they all go into this, usually this direction. Okay, and that means it being the force was happened this way. The force was exerted this way. So it, a blood spatter will tell us quite a lot. What about the angle? We talked about the angle as well. We take a blood drop, we take the length and the width. Okay, we divide the width by the length. We get a number. We take a invert sign of that, and we get an angle. So that's an example. If a drop of blood or a spatter, a smudge, any types of blood has the width of 4 millimeter, length of 8 millimeter. So we get W over L, we get 0.5, we take inverted sign, we get 30 angle. So the impact angle with 30. Okay, that explains from which side on how this blood was spattered. Okay, that is enough of blood stain analysis. I think we covered this a little bit as well. Other than blood, other than salivas, all these physical evidence, we have two more important physical evidence. Very important physical evidence. One of them is hair, the other one is fiber. So there is this exchange principles called Lockhart's. We're not going to go into the detailed philosophy of what's Lockhart principle, but it says every contact leaves a trace. So if you've been in a place, you will leave a trace. Simple as that. Okay. So you might leave some hair, you might leave some fibers from your clothes, okay, shoes, anything you are wearing. Okay. So hair analysis, we'll go back to it in a minute. Fiber from our clothes, you can have natural or we can have synthetic. You see the synthetic are smooth, the naturals are not so smooth. The natural fibers that we can leave in a crime scene, like cottons and wools from our clothes, sometimes from carpets, in the car boots, anywhere. Okay, the synthetic ones that is been specialized in made, they are nylons and polyesters. Okay, the detailed chemistry of nylon and polyesters is in fiber analysis is paramount, but we're not going into that detail. How do we collect them? We use tape, sticky tapes, we use tweezers, and usually we vacuum as well. If it's a carpet, or if it's in a car, or somewhere that we can actually vacuum, we vacuum the whole area. We pick up all the fibers, natural and synthetic, and we take them to the lab for analysis. Okay, what we're looking for is matching. Okay, so if you find, let's say you find a natural fiber, looks like this, on the victim's body, that comes from a sweater or comes from a wool jumper that a suspect's wearing. It's a quite good evidence that this person actually been near this victim somehow. That's why the fiber analysis match. The other one is hair. Hair is very, very important, paramount as well, because hair is very specific to all of us. Okay. Cuticles is the outside of the hair. Again, we're not going into the details of anatomy of hairs and human bodies. This is done in biology. We're not going to go into the details. But a hair strand will have an outside cuticle, the cortex, which is between, and we have something else called medulla. Medulla is the core, the inside. Okay, between the medulla and the cuticle, we have cortex. Okay, it is responsible for color. Okay, the medulla is the core, the inside. The cuticle is outside, and the cortex is right in between both of them. They contain the pigments, which is responsible for color. Now we have two types of hair sample. You could have the root, which is very important. You could have the shaft. The shaft is as important as the root, but the root is more important because it contains nuclear DNA. Now you understand DNA, you've done DNA, and you know you have nuclear DNA and we have mitochondrial DNA. But in the roots we get, if you're lucky to get hair with the root, then you'll be able to do nuclear DNA analysis, which enables us, which gives us the power to identify the individual directly. Okay, so this, you know what I mean by that. So we can say, look, this DNA came from this individual. We're really looking for the root of the hair strand. But if you don't have that, if you're not lucky to have that, the shaft is not that bad as well. It contains mitochondria. Mitochondrial DNA, it gives you a maternally inherited class characteristic. This is related to maternal inheritance. Okay, it gives you some idea. Is better than nothing, but we're hoping to get nuclear DNA. So what is the investigation tip? The presence of root determines the testing path. So if you have the root, you will do nuclear DNA analysis. If you don't have the root, you must use the shaft to do mitochondrial DNA analysis. Now, in the upcoming lectures, maybe next week, a week after, we're going to focus fully on DNA analysis. So don't worry about it. This is just a reminder. Yes, again, this is still fiber. We can see the difference between clearly between synthetic, nylon and polyesters, and natural cotton and wools. Again, so the other part is firearms and ballistics. So we focus on, let's quickly go back, blood. So we started with fingerprint because I promised that we're going to focus on physical evidence, fingerprints, different types, and footprints, tire marks, tool marks, everything else. Then we quickly covered biological evidence, but because we covered it before, blood and saliva and semen. We already know much about them. And we did on physical part of blood, blood stains and the patterns analysis. So we focused on different types. And then we did look into fibers and hair analysis. They are very good physical evidence. And then now we're going to focus on another highly important physical evidence in a crime scene, which is firearms and ballistics. So again, like every other part of forensic investigation, firearms and ballistics is the major area. And we only know just the general, we only have general idea about firearms and ballistic, and there is people in the forensic science services everywhere in the world, if they have it. I mean, what I have seen is UK forensic science services. There is people very specific, highly expert in firearms and ballistics. They know everything about guns, about powders, about bullets. But we don't need to know that because we don't want to be an expert in that area unless in the future you're going to focus on that side. But what we need to do to understand bullets in general. So a bullet, a projectile that will go get out of the shell and does the damage. Okay, that's the bullet. And number two is the case, which is the whole container. The whole container. And it depends on the types of bullet. Is it small bullet, big bullet, is it a missile or whatever it is? But they are all similar things. So you have a case. And the third one is the powder charge. So you have a powder here, okay? And this powder is the propellant. The propellant is the actual thing that pushes the bullet out. And in the back of the shell, we have the trigger, or what we call it, primer. Primer. This ignites, okay? Okay, this ignites, okay? This is create a spark and starts firing the powder, the propellant, and that propellant will explode and push the bullets out. So this is the four parts of a simplistic, a simple bullet. What do we looking for? What do we looking for in bullets and in firearm and ballistic? Okay, rifling. The word rifling is shooting a bullet out of a rifle. That's the process. Rifling. Okay, leaves marks. We call them lands and grooves. As you can see, lands and grooves. Okay. He'll carry. Okay, lands and grooves. Okay, creates unique striations on the bullets. Striations, like I said before, he'll carry. Okay, okay, so it leaves different striations. Okay, on the bullet, and we will match uh, these striations with the guns and with the bullets that we find in the crime scene. So how do we do that? You go into a crime scene and you pick up a bullet or a shell or anything related to firearms and ballistics. Gunpowders as well. You pick up all that, you take it to the laboratory, and you picked up a gun, okay, from a suspect. So what we do, we compare the lance and groove of the gun with the bullet which was fired to target the victim. Okay. Another thing, gunpowder residue, DSR. So we pick up gunpowder with adhesive stubs, very special um, sticky tapes and containers. We pick them up and we take them to SEM analysis, scanning electron microscope analysis. If you get time, toward the end of the semester, we'll look into different types of microscopy. What we're looking for in a GSR gunshot residue. Look, gun, gun, G, short residue, GSR. We're looking for three materials, three chemicals: lead, barium, antimony. They are the major compositions of GSR, gunshot residue. How do we collect them? We use adhesive stubs. Again, this is a very specialized area. You don't need to know exactly how they're going to do it because you will never do it. It's not your job. You know, it might be your job to analyze it in laboratory, but it's not your job to collect it. How do we detect it? Like I said, scanning electron microscopy analysis. This is a SEM image of a gunpowder particle. It's a beautiful scanning electron microscope image. Okay, we already talked about saliva so much in the previous lectures, but we're going to talk about how we collect saliva evidence. Not what is it. I know saliva is a biological evidence, but how do we collect them? What are the sources of that thing? Well, one of the important sources is bite marks, believe it or not, as you can see in here. You know, they inside these bite marks, yeah, people do all sort of things, you know, during a crime, unfortunately. So this will leave saliva here. Special people will pick up this saliva and will send it to the lab for analysis. Vessels, anything to do with physical objects like cups, glasses, you know, plates, forks, and knives, whatever. We just call them vessels, like things like that. That is, people usually leave lip marks, fingerprints, you know, they drink out of it and they leave salivas there. Another thing is, you know, nowadays is rare because people don't smoke inside premises. Is not allowed in. I'm talking about the Western world. So, but usually, if somebody wants to kill someone, they don't care about smoking, so they will leave a cigarette. But you know, without thinking about it, believe it or not, they come outside the house, or let's say they did a rape case, and or they raped somebody, they strangulated somebody, killed somebody, did something, and they're nervous, they start smoking outside, and they leave, they throw the cigarette butt on the floor, and the police will come and nicely pick it up. Okay, on here we definitely have saliva, and we find that we collect that saliva and we take it to the laboratory. What we do first, we do a presumptive test. We use an amylase enzyme to test, and then to be 100% sure, we do a confirmatory test. We do DNA analysis. Again, don't worry about DNA analysis because we're going to focus one full lecture on DNA analysis. How we pick it up, we use buccal swab kit. Okay, just like you know, earbuds. You know, we use especially to pick up this saliva. And to be honest, it's not an easy process, especially here on a cigarette butt and on a cup. It's not easy, but special experts, they can collect these evidence. Another one, semen analysis. So again, we talked about semen for a bit, and you've done the biology of semen, and you know what it is, and you know how it works. So we're not going into details of these really important biological evidence. That is usually happens in case of rape and murder. Some people do kill someone, rape them before that, and kill them. Unfortunately, this is the reality of it, but we have to be prepared. So what we do a presumptive test using acid phosphatase test. Now, this is a special test, and then to be able to fully identify it, we we need to use microscopy to see the actual sperms, okay? And we know they are very specialized to each personnel. Okay, or we can do a PSA test. A PSA test, again, I'm not going into details of these tests, okay, because this is a special area, but you only need to know to do presumptive tests and a microscopy test or PSA test. PSA test usually done for on men for prostate problems such as prostate cancer, prostate swelling, prostatitis, whether it is chronic prostatitis or uh, infection prostatitis. We do PSA test to see what is the situation with prostate. So it's specialized to men. Okay, special investigation, a sexual assault. Okay, let's say, how do we collect the evidence? Okay, we need to be able to, all these kits, as you can see, oral swabs, sexual forms to fill in, trace evidence, general, you have all things to be able to use in a sexual assault situation. So what we do, what is the workflow? Is very important, time sensitive. Okay, so need to be very quick. Why? Because you don't want biological sample to degrade. Whether it's semen, you know how sensitive semen is outside. They can't live sperm, they can't live outside of the body. They need a special environment, humidity, heat, and everything. So again, we're not going into detail of that. So it needs to be as quickly as possible to prevent biological degradation. Consent. And we talked about that one big lecture. Are we going to take these sample with the consent? They accept, the person accept the sampling or not. Documentation is the first mandatory step. So if they refuse, you need to get a court order. We talked about this before, okay? Victim protection, you need to protect the victim. They've been raped, they've been harassed or whatever. They've been hurt as well. So you're not going to, expose them even more. Medical care and dignity take priority. So the first important thing is medical care. Are they safe? Safe and healthy? You need to look after them. And then are they dignified? Okay, you're not shaming them because of you taking a semen sample, whether it is from a male individual or inside the body of a female individual, because that's what we're looking for to establish the fact that a rape case happened. Usually we need some sort of evidence that a semen was involved in the female body. Okay, so again, this is a huge area, and I'm not going to dive into details of that. Just an idea. What are the kit contents? Swabs. Okay, these swabs that we can use for oral swabs. Like usually, you take a DNA sample from any person. They use oral swab, and again, you need vaginal swabs. Okay, to pick up any residues, whether it's a semen or anything else. Uh, transferred from the male into the female, and or vice versa, something from the female into the male, and then it can be used for anal swabs to pick up anything from the anal area. Another thing that we're using traces, little things, okay, fingernail scraping under fingernails. Usually, where there is a rape case, there's force involved. Okay, whether that rape case escalated into a murder, it depends. In both cases, there will be force involved. There will be fingerprint scraping, so fingerprint will be involved. Fingernails. Nails will be involved, scratching and attacking and all those kind of things. So we leave skin residues under fingernails. Okay, pubic hair combing. Sometimes we have to use a comb here, shana in Kurdish, so to pick up hair in general, whether it is hair from the head or the armpits or the pubic area. Okay, to establish that these person been in contact. Again, clothing collected in paper bag. We need to these paper bags to collect all the clothing, underwear, and everything else. Why is that? Because you don't want in a plastic bag, because we talked about mold and degradation, heat and humidity will cause moldy and degraded biological sample, especially semen. And what we do, we take a reference. A reference usually it's called a blank, to eliminate the victim. So there's been a victim, okay, whether it's murdered or still alive, still a victim, okay, but people, rape victims. Nowadays, people would like to call it a rape survivors rather than a victim, because we don't want to victimize them. We want to label them with a survivor. They're stronger people. They survive the horrendous rape case. So, rape survivor, we need to take a DNA from this person, whether it's a male or female. It could happen, believe it or not, it could happen to any individual, male or female. So we take a DNA sample as a reference to eliminate this person from the scene, because we already know this person been in the scene. Okay, sexual assault evidence kit, SAEK. So yes, we talked about it. Inventory. We need a swab. We need packaging. We need scraping. We need the reference DNA. Okay. We need a victim consent, the special forms, and protect the victim as well. And then we need bridging clinical care and the crime lab. Okay. We focus on that before. Clinical care and crime lab. So in clinical care, uh, we care about the welfare, the safety, the health of the individual. And in crime lab, they care about evidence to prove a crime has been committed, and they want to collect every evidence and ensure that they are they ensure that they are admissible in court to solve the crime. Case study, another case study, the shooting scene. Okay, in a shooting scene, we will be looking for chemistry, obviously gunpowder residue. It could be on hands. The person shot the gun, so left some residues on the on their hands. So we're using special techniques such as scanning electron microscope, like I talked about it, to find out if there is any gun residue. Ballistics, we already talked about it. We need to look for the ballistics. What type of gun was used? What barrel was it? And what type of bullet was it? And striations as well is very important. Lands and grooves, they should match the suspect's gun. And we talked about it. So you have a bullet, and that bullet, if that bullet left the barrel from that gun, then they should leave special lands and grooves, which is very specific to this gun. Okay. What do we else look for? We look for fingerprints. Okay, footprints, bite marks, any physical evidence that links the suspect into the crime scene. So, do we have any fingerprints on this trigger here, this area? Do we have? So we take the gun to a laboratory. We pick up all the fingerprints, any all three types of fingerprints on the gun, and we try to match it with the fingerprints of the suspect. If they match, that means this gun was in the hand of this suspect. Then we're looking for other things like powders on the hands and things like that. If we have all these three evidence and they are all solid, then we will have a court case, legal case, and we take it to the court, to the jury, and to solve it really. Okay, that's another case. Right. Another case study, the assault. So in assault, somebody's been attacked. Whether it was killed or not, it doesn't make any difference. A crime being committed. Is it a normal assault or is it a rape case? If it's a rape case, it makes it more serious. So what we're looking for biological evidence and physical evidence. So biological evidence here and physical evidence. Usually in biological evidence, we look for saliva, for blood, for semen. If it's a rape case, obviously there will be some semen involved, like we talked about it. We identify the semen, and we look into the we do microscopy tests and we do PSA tests and we look into the types of the sperms and everything else. And we do DNA analysis. If the DNA matches the suspect, then you have a case. Okay, there's a DNA. You have a case. Anything else is a bonus, is complementary. So if you have evidence, physical evidence, which despite the biological evidence links the suspect into the crime scene, it's bingo. It's even more stronger case. What sort of physical evidence? Okay, so in the crime scene, you pick up a very special fiber, and that special fiber is from polyester, and it's from blue polyester. So you have two types of characteristics. The fiber is from polyester. Polyester is synthetic, and its color is blue. So this is quite obvious. Okay, where do you pick it up? You might pick it up on the body of the victim. Okay, or you might pick it up on the floor of the crime scene, or you might pick it up from the carpet, and the carpet inside the boot of a car. Anyway, you pick it up in a crime scene. We talked about different crime scene. We have a crime scene where the crime happened, primary, and the secondary crime scene where the body was dumped. So you could have it could be in the primary scene, or it could be in the secondary scene. Wherever it is, it doesn't matter. We pick it up, we analyze it. It's blue, it's polyester. Now you have a victim. That is on the victim, and you have a suspect. That suspect wears the exact shirt. That shirt is polyester and it is blue. So that is real. Like I said, is not a definite, okay, but it narrows it down. With the physical evidence and the biological evidence, there's no way out for this suspect. This suspect will go down. Okay. What is the verdict? Independent sources, bio plus and trusts, create the strongest case. So this is the strongest case in here. Is not disputable. This might be disputable, but this is complementary. Okay, we're saying, yeah, you have been in this crime scene, and now we have your biological semen profile as well. Okay, applied forensics. Okay, yeah, basically that was the two cases together. So the case of the shooting, evidence A, we're looking for gunpowder residue, gunshot residue detected on suspect's hands, chemical. And other evidence is from the gun, from ballistics evidence. Okay, striations from the gun, okay, from the barrel of the gun. Okay, they match each other. Evidence C, or Third types of evidence, latent print on firearm magazine. This is criminalistic. So we have a chemical, ballistic, and criminalistic evidence that fingerprints on the magazine or on the handle or on the triggers of the gun. Okay, so this way we suspect we link the suspect into the weapon and to the discharge. Okay, what about the assault case we just talked about? We're looking for evidence A, semen identified. Okay, biology. Evidence B, DNA profile and matching, biology. Evidence C, red wool fiber found on victim's jacket or blue polyester traces. That is strong evidence as well. So what happened? What is the result? Suspect placed at scene via Lockhart's principle. What does that mean? It means this suspect, this is the crime scene. Okay, this suspect should have been in that crime scene to leave traces and biology and DNA and semen. Okay, and obviously we're going to prove Lockhart's principle. It says every contact will leave a trace. So if this person been in this crime scene, they left some kind of trace. That kind of trace can go back to any of them, any evidence that you might think of. The role and responsibilities. Very quickly, your role as a laboratory scientist is scientific analysis, confirmatory test. You see the test that chromatography, SCM, microscopy, and everything like that. Reports writing, you write the reports to the court. Expert testimony, you might be asked to go into court and give your expertise in the court to the jury and the judge. Objective finding, what is it you found? Okay, we talked about this as well in detail. Other thing is, on the other hand, we have forensic police. See, the difference between you and the forensic police is huge. Okay, what they do, they skewer the scene. So they make sure the scene is tight, nobody goes in and out of the scene, no evidence being moved, and they're going to control everything. They document everything. They start interviewing witnesses, people that been around that area from the window, wherever they seen, and they start arresting suspect. People around the area, maybe they are suspect. Somebody's already been identified as a suspect, so they start doing arresting. And they start collecting evidence. You see, we're not collecting evidence. They will collect evidence for us and they will transport it to us, and we start doing the investigation. What they do, they start or initiate chain of custody. So chain of custody is actually shared between both of us, between the police and us, as laboratory scientists. So they started, they collect evidence, they sign it, date it, and everything, like we done before. Then they will send it to us, and we will carry on doing the chain of custody because it's a very important aspect. Protocol and composition exams. Well, one question say name the three elements in gunshot residue or gunpowder residue: lead, barium, antimony. How do you pack wet blood-stained clothing? Air dry completely, then place it in a bag. Why? Because preventing mold and degradation. We already done that. You see, this calculation is quite nice to find the angle. We already done it, and there's another example for you. Please look into it. And and other questions that come up, the math, and this is gunshot residue, packaging, and key definition. You need to be able to define Lockhart's principle. Every contact leaves a trace. Chain of custody documentation record to prevent inadmissibility. We have done this properly before. Presumptive and confirmatory test. Possible is presumptive. Definite is confirmatory, and we've done a lecture on it. The final takeaway for you is very important. Forensic science is the bridge between the truth of the crime scene and the justice of the courtroom. Okay, You need to be objective. Let the evidence speak. I mean, we've covered this entirely. Never do any bias. Never give any opinion. Okay? Science serves the truth, not the prosecution or defense. The science is there to help identify the truth, not helping the prosecution because you don't like that person, not helping the defense because you're against the police or whatever. Nothing. It's not our job. Let the science speak. Okay. Scientific rigor. Scientific rigor. Okay. What is it? Adherence to protocol and chain of custody. You need to be, we talked about that. Yes. Protocol. What is it we do? We decided to do this protocol and we're not going to deviate from it. We're going to stick to it. And we do the chain of custody is very important. We already covered it. They ensure justice is based on facts, not errors. So if you do everything properly, okay, if this person goes down to jail, it's a justice. Whether this person is my brother, my father, or my family, or a stranger, it doesn't make one little bit difference. Okay, justice been achieved, and there's no any errors. Okay, we talked about it. Documentation is very important. If it isn't written down, it didn't happen. And again, previous lectures we covered. Detailed notes are your voice in court years later. So if you have all the details written down and signed and properly saved, that will help you even not now, many years later, if this investigation reopens. Okay, and the scientific of the science of truth. Okay, we like to call forensic science the science of truth. Whether this happens or not, forensic science makes sure that we have the answer. From the chaotic scene to the definite report, forensic science is the rigorous application of multidisciplinary protocol to serve justice. What does that mean? It means in a crime scene, somebody's been killed, raped, hurt, whatever has happened. It's a chaotic scene. Nobody knows what's going on. Okay, what we do from that chaotic situation, we create structure. We create definite report. We have a definite answer. Okay, we know who has been there. We know why this been done. We know who should go to prison and who should be free. And that's the beauty of forensic science. Okay, it doesn't, if you follow the protocol and you know chain of custody and implement the rules as they are, you will be happy that justice is served. Thank you. Okay, in terms of self-reflection, you know what to do. I'm not going to take your time. You should be able to write your self-reflection and be ready for inspection, because I will. We're going to go back to classroom and I will check, especially for the self-reflections of these weeks that we're learning online. So please be vigilant and have all your self-reflection written down, whatever system you're using. Okay, and make sure that you understand how we're going to grade your self-reflection. Thank you. Okay, we're going to start.